All right, and it looks like we are live. Let's make sure. How's everyone doing this evening? Welcome back from a nice holiday break. Hopefully, everyone enjoyed themselves. Yep, we're live on YouTube. Make sure that's all quiet. Okay, good deal. All right, so I hope everyone had a wonderful holidays. We had Christmas and Hanukkah at the same time, which is pretty cool. We had a white Christmas, which is so incredibly rare. I think that should be a huge celebration right from the start, right there. I know we haven't had a blizzard or any of the major winter storms, especially the one that we were hoping for, but we had a white Christmas. And that, ladies and gentlemen, is incredibly special because you have less than a 10% chance of that happening. So, hey, we're off to a good start, I think. And I have some good news as far as potential going forward. I'm going to talk about that quite a bit tonight. Also, want to let you know I just got done doing a great interview with Lee Goldberg from ABC 7 in New York uh, on the podcast Whether or Not. And as soon as that drops, I will share it on my socials and you guys can go check it out. We had a lot of fun talking about, the unfortunate fire situation in California, the winter weather potential for Saturday, which is looking rather minor. We'll talk about that in a moment. Also, what to expect for the rest of the winter, and we'll see how much they edited out. The rant I had about social meteorology, in terms of some people posting or sharing snow maps are like 15 days out and stuff like that. You guys all know where I come from in that respect, but I kind of shared my thoughts on that. So that was fun. So let's take a look at the data here. Let me see if I can switch that over. And good deal. We're here and ready to go. Luckily, we aren't too rusty. Now, right now, it is cold, very cold out there, with temperatures ranging from the upper teens over the northern interior, mid 20s along the coast. It feels like it's in the single digits and teens because of these gusts that are in place at 10 to 20 miles per hour sustained. Gusts at times almost up to 30 miles per hour in some locations. When you get temperatures this cold, which is already cold enough, but at least you could deal with it, right? But then you throw in the winds, knocks down your wind chills into the single digits. It is not fun out there at all. We also have a few flurries here and there around the Poconos and Catskills, some lake effect snow. You got a nice little low pressure system. And then here is our troublemaker that's going to be a real issue for the Southern Plains and the Tennessee River Valley. Let me tell you, I lived out in these locations here. And when it snows down here, let me see if I can, yeah, right about there. I lived in those areas. And when you get snow in those areas, let me tell you what happens. One, everyone is basically staying home and they don't go anywhere and they watch TV and then they can't do anything. And what I was told is that when you get heavy snow in these locations, basically what happens is that they wait for God to remove it and let it melt. That literally was my experience living in Oklahoma. We had 3 inches of snow in Oklahoma City, and you would think that there was like 16 feet of snow on the ground and that the world was coming to an end. So when you get a major storm down in those locations like that, it's really crippling because they don't have very good plows. They don't have treatment for their roads. It is really a disaster. So when you get heavy snowfall in these areas, it's not fun at all. So we're going to be watching that unfortunately unfold. A lot of really dangerous weather taking place over the past couple of days between what's going on in California with the forest fires and now this winter storm impact. So, why aren't we seeing a storm? Let's go over why we're not seeing a major winter storm here so that way we can understand what we're looking for in the model guidance when we do have a major winter storm. So, the first issue here is this trough right here. Okay. The fact that it is this positive. This extension, okay, this is the way that it's oriented is such that it cannot catch up to the polar trough that is up here. Okay. So as this is diving south, this is taking too long to catch up to it. So as a result, you end up with a storm that gets sheared apart. It can't mature. Meanwhile, this feature up here is going to really intensify. And as it swings down, it is going to get stronger and stronger as it's swinging through the region. Now, a lot of people are starting to notice this. The European guides is getting better and better in illustrating that this is going to be a more robust system, but that's not going to change the forecast that we have in place here, where we're not really expecting much in terms of an impact. In terms of the other reason why this is not a major winter storm threat is that the orientation is all wrong. And what I mean by that, and make sure I get the right marker here. When we study this situation with this ridge axis here, it is too far west. What you want is the ridge axis about here. Because then when you have the ridge axis here, basically over the Rockies, that leads to a greater amplification. And you can, let me fix this here. Greater amplification in terms of a deeper trough. And you can pull off a negatively tilted trough when you have a ridge axis in this area. But in this case, because the ridge axis is so far to the west, what you end up with is a much broader trough. And so with a broader trough, these disturbances that are down here, well, you end up having to force a perfect phase or nothing at all is going to happen. And that is essentially the problem with this winter storm threat is that the orientation here is just all off in this scenario. So that is what we're looking at with the upper level winds. The Atlantic situation is perfectly fine for setting up a winter storm. The problem is the West Coast is just a little bit off. So when you have that type of difference in your short waves orientation, you end up with this feature where your moisture transport is not as robust. So you can see it's starting to develop here. It's not bad for a southern plains winter storm, but as this is getting going in and organizing, you're going to notice in the model guidance that it's not expanding further north. So let's take a look at 500 millibar PVA here. So a lot of people are making a big deal, and I saw this online. I saw a couple posts on X and a couple posts on Facebook of some excitement about this feature here being more robust. And so as a result, hey, look, maybe this could be something a little bit more than what's being forecasted. So yeah, there's definitely strong lifting here. When you have this type of spread here, let me just try to get the right area right here. You see this right here? This spreading out in the atmosphere. This allows for a lot of rising air. So yeah, this is definitely going to be a very vigorous, strong shortwave in the polar jet stream in the while it's moving through the northern Atlantic and the in New England. There's no doubt about that. But notice, look what happened to the shortwave in the subtropical jet stream. It is sheared apart. There's almost nothing left here. It's like strung out like spaghetti. Okay, so it's a very, very sheared apart trough here that isn't able to do one of the most key factors that is part of the subtropical jet stream, and that is to transport moisture out of the Gulf and into the polar jet stream. It can't do that in this scenario because it's getting ripped apart and it's far too weak. So we can study this, and we know this by what's happening here in the precipitable water values. So while you might be hearing some people chasing the European guidance, new updates with a stronger, more vigorous shortwave in the polar jet stream, all you need to know, all you need to study is whether or not the precipitable water values on Saturday morning are stronger. And this is the latest 18Z guidance. And what we see here is, yeah, stronger lifting, absolutely. But what is it lifting? Not much in the way of moisture. So as a result, this could produce a fluffy half an inch, maybe an inch and a half down towards Monmouth and Ocean counties. Maybe you might pull off 2 inches around Cape May and down towards the Delmarva Peninsula here. But there isn't a lot of moisture to lift. So if you don't have a lot of moisture to lift, you're not going to have a lot of snow, no matter how vigorous a short wave is. You might end up with a quick, heavy burst here and there, but that's it. Okay, because the amount of moisture you're working with is not there. Now, when we were looking at the potential for a major winter storm, part of that had to do with the fact that you had an intensifying low pressure system off the coast, and you had enough time to draw moisture in from the Atlantic to enhance the snowstorm threat. But in this case, you simply just don't have that because your low pressure system, well, it's well to the south. So in this scenario, everything's getting kicked out. You can see here on the 500 millibar PVA, everything's rapidly getting kicked out. All right. There's no chance for it to slow down. There's no chance for it to stall or retrograde. And the reason why is because you already have other disturbances diving into the West Coast. This basically rotates under the block in the Atlantic, and this just comes right in and kicks this right out. So, plenty of cold air to work with, but just the timing of these short waves are just off right now. And so that's how you end up with this scenario. I was concerned earlier on, just 2 days ago, that this could be a more robust system. And yeah, I was a little studying the GFS. Not that I trust that model guidance at all, but the only reason why I was a little hesitant to write this off very quickly is that typically the European model guidance has a real difficult time handling these short waves. And the upgrades that we've been dealing with, that we've been seeing with the European guidance, was supposed to answer, it was supposed to correct this issue. But you don't know until you're in that situation whether it actually has been corrected. Well, it has. And what that basically means is that the wonderful people who have built the European model guidance has essentially corrected a major bias in the model guidance, which makes it even better. And you throw that on top of with some AI help in terms of observations and filling in the blanks there. Well, let me tell you something. We're dealing with a powerhouse when it comes to model guidance, and this one of the reasons why I lean on the European guidance so much is that it just does a better job in handling these disturbances. But I was a little doubtful just because of the history of this model guidance having a difficult time with disturbances exiting out of the desert Southwest. But tonight, I think we could say that bias has been basically corrected, which is really, really impressive. So, again, that's what leads us to a minor event up here, maybe an inch, 2 inches at most, maybe down towards central and southern New Jersey. It is going to be a real mess in Arkansas, northern Georgia, northern portions of Alabama and Mississippi. Look, these people are not used to this type of snowfall. So, North Carolina, my parents moved away from New Jersey to get away from snow and ice, and they walked right into a snowstorm here. So unfortunately, I warned them when we were on Christmas break. Like, hey, be prepared for some snow down there. So hopefully they are going to be in good shape, but they're in the HOA. They'll get taken care of. So that's our storm. So obviously the question is, are we going to have any winter storms this year? Is it going to be perpetually dry and cold? Well, let's dive into some more data and take a look at why I don't think we will be. Most of this winter thus far, we have had the MJO in phases 4, 5, and 6. It's been cold. It's been impressively cold this year, especially compared to the past couple of years. So we have the cold air, but we haven't had the support from tropical forcing. Now we are moving finally, after years, we're finally moving into a favorable phase, tropical forcing, with plenty of cold air. We're moving into phase 8, 1, 2, and 3. For January into February, what you want to do is be in these phases. And based on your lag time, this basically supports a active weather pattern. Okay, we're not going to touch the temperatures just yet, but this certainly supports an active weather pattern in the subtropical jet stream that will be favorable to interacting with the polar jet stream. And it tends to support more convection around the dateline and tends to support a better potential for cyclogenesis on the East Coast. So this is a fundamental change from what we've been seeing for going back to the late fall. So this is more of a La Nina like pattern. This is more of a storm track position to the northwest of us, generally dry, which God knows we have been. This has been our transition where we started to see a little bit more storms, but things don't exactly work out. And now we're finally moving into a more favorable phase. And so that's why when we look at storm potential in the long range, we could put a little bit, not a lot, just a little bit more confidence in the potential for winter storms in these long range outputs because the tropical forcing would support this scenario. And this would support an active weather pattern through at least early February, if not longer, depending on what happens after this point. Some of the longer range guidance takes the MJO into a neutral state and then trying to push it back towards 8 and 1. But when you get out beyond this forecast period, the MJO forecast becomes a lot less reliable. So it's best not to put a lot of stock into it. But what we do know right now is that phase 8, 1, 2, and 3 are locked in to set up for the rest of January and into early February. Meanwhile, hey, our polar vortex continues to stretch and stretch and stretch. And the more that we see this at 10 millibars and 50 millibars, the more that this supports in the polar jet stream a continuation of cold air being transported into the eastern two-thirds of the United States. Now, this doesn't mean that it's going to be perpetually cold now through the end of February, but any type of warm up or relaxation in this type of signal here is going to be relatively short. And not only that, but when you see this type of signal, it tells you that despite a strong polar vortex signal, that the declining QBO moving towards below 10 meters per second, based on some of the observations at 30 and 50 millibars, that this type of stretching is going to continue on. We could see this continuing into February, which would put the influences past mid-February, possibly touching into early March. So this looks like the more we see this, you have a higher potential for a chilly spring, which gives you the potential for maybe some winter storm potential in early March. I'm not guaranteeing that, but if we continue to see this type of theme, you have to at the very least put um, that potential on the board. Okay. And this also tells me that in terms of, breaking down the potential for winter storms, the one thing that won't be lacking will be the cold air. And when you have this type of signal showing up in the guidance, this supports that the potential for a little bit more negative NAO. Certainly, nice robust ridge over the western United States. You would like to have your ridge axis in this scenario. I mean, take a look at 500 millibars, a little bit closer to the Rockies rather than the West Coast. And we start to see that signal playing out by the middle of the month and continuing on through the end of the month, where you get that shift and that support for a ridge more tending to be towards the Rockies, and that would support a little bit better potential for amplification on the East Coast. You're also seeing that on the operational guidance. So initially, like where we are right now, where your ridge is pretty much focused in the Gulf of Alaska, cold, yes. Orientation for these troughs doesn't work. But as we move further into the forecast, when you start to see this signal popping up a little bit more, especially 5 to 7 days out, that increases your potential for cyclogenesis on the East Coast and for a storm to cut up through our coastal waters rather than heading out towards Bermuda. So these are signals that you should look for when you're studying this model guidance. Again, there's our ridge axis approaching again. Again, it doesn't have to be locked in over the Rockies the entire forecast period. It just has to be in that place at the time when the storm potential shows up. And then this really, really caught my eye. This signal out here, you're already starting to see a slight negative tilt. You do have a nice 50-50 low setup with a nice negative NAO setup. The ridge axis, you can kind of see one over the Rockies. It needs to be a little bit more fleshed out. But you see what the potential is with the next two storms on the 12th. I'm sorry, not the 12th. The 17th and the 23rd here, that are really showing up as something that really needs to be watched. And again, this is a little bit more favorable because it falls in line perfectly with these phases. So that's why I really, when I saw this, I'm like, geez, this really has something that we need to watch here. And in the meantime, plenty of cold air. Notice like anytime that we get a little relaxation, we set right back in with more cold air coming in. So there is no lack of cold air. The question is with these short waves is whether or not they'll start to pull this tropical moisture down the Gulf Coast up towards our neck of the woods. There's going to be a lot of clashes between this cold, dry air and all this moisture. And again, let me go back to 500 millibars just to show you the potential here in these type of storms. Pull up the 12Z. See, let's see here. So one threat right there. Then here comes your next threat. This threat is showing up around the 22nd and 23rd. Again, I don't want to take anything verbatim, but when you got a strong shortwave coming in, interacting with another shortwave and a subtropical jet stream, that is textbook for a lot of potential here. And then you get it going to a negative tilt. You can get a storm setting up to the north of the Bahamas, tracking right up the coast, creating all sorts of havoc. So that's something that we're definitely going to be watching out for. I expect it to be, showing up and then disappearing on the mile guidance back and forth, but that time period is something that I'm going to be watching very carefully. And again, just to go over, we got one storm threat that's showing up here about 12 days out. And you don't want to take anything verbatim here, but this whole time period here, if you get that blocking setting up, it makes sense with the tropical forcing, makes sense with what we're seeing with the polar vortex. Better potential for some storm activity, and then we'll see how everything plays out. So, a lot of potential, and I think that we're going to continue to see that potential going forward over the next couple of weeks. Whether or not that means you're going to see heavy snowfall in your backyard. Don't know yet. Can't make that bet. Can't make that promise. But I can tell you that anyone that's saying winter canceled, you might be in for a surprise. Granted, we've missed some storms. It's been dry and cold for many of you. But on the other side, we've had a couple of chances. We had some pretty good snowfall in locations where, quite frankly, you end up mostly with rain. Excuse me, this time of year. We're talking about Cape May, Atlantic City, Wildwood. So, sure, the northern interior, mostly you've seen a lot of lake effect snow type scenarios. Good coffee. But understand, we got a long way to go. And, I've seen plenty of times where the winter is relatively quiet but cold, and then all hell breaks loose in mid January and early February. And the narrative of the winter changes completely. So now, as always, we're going to take some of your questions, and we'll start off with the premium chat room, and then we'll check out social media. And Susan, my lovely wife, will let me know what is going on X and all that stuff, and see who is being a nutcase out there, right? Okay, so let's see. Card, it's good to see you again. Hopefully, you had a great holidays. Will the interview be embedded on the Discord as well? Yeah, I'll put it on there when I get it. Absolutely. Let's see here. Do you see anything in the upper level pattern that the future events would make it more likely for the Western Ridge to be better placed for the Northern Mid Atlantic? I think the fact that we're seeing that change in a tropical forcing is going to go a long way. There's a bit of displacement between the polar and subtropical jet streams, especially with the support for more upper level lows around the desert southwest, which is typical when you have this kind of muted tropical forcing scenario where you have some hints of a La Nina, but it's not very well established, and your MJO has a little bit more influence. So you're getting a lot of mixed signals. So when you have this upper level low over the desert southwest, for one, it messes with your statistics with the PNA. But I do think that with your MJO phases in 8, 1, and 2 over this time period, and eventually 3, as we head towards early February, that is going to open up the potential for your ridge axis to be more likely to be over the Rockies and more favorable than not. Looks like there's a setup potential for good cross-polar flow from Siberia into central and eastern U.S. Yeah, if you're looking for a warm-up anytime soon, that is pretty much gotten the kibosh. I was thinking in my original thoughts for this winter that, hey, there'll probably be a January thaw or warm up late January into early February. But the way that we're seeing the evolution of the polar vortex, and this was warned back in October when we talked about the stretching and the weakening of the QBO. When you have those signals, that tells you the cold air is not going away anytime soon. Sure, you might warm up into the upper 30s, maybe even touch the lower to mid 40s for a day. But in this scenario, you just keep on getting knocked back down to below normal temperatures. And this is going to probably set up a winter statistics where we have below normal temperatures for this winter. The problem is we also have below normal precipitation, as you know, thus the lack of snow for many locations. But the good news is I do think we're going to see that flip. And I do think we're going to see storms. I would be very surprised um, if we go through this phase 8, 1, 2, and eventually 3 through the end of this month into early February and not have at least one moderate to major winter storm impacting the northern mid Atlantic. So I'm expecting that. Um, are the Are the southwestern upper level lows also causing the winds that are helping fuel the California fires? Yes, unfortunately, the orientation of that upper level low and the surface low is enhancing the Santa Ana winds. It's what drives it. And unfortunately, it just feeds on itself. It gets very dry in Southern California, and you get the right spark and you get those winds going. The tremendous heat feeds back on that and leads to even stronger winds. So, what's happening is that your air is rising so fast in the fire that it creates a low pressure within the fire because you have all that rising air. And so you create a vacuum. And so it's trying to fill that vacuum. So then what you end up with is these very powerful winds. And then these very powerful winds via Coriolis effect uh, helps to expand the fire because now you're blowing those ambers out ahead of the fire to create even more fires. So it's just a complete disaster. And then that leads to a feedback where you basically end up creating this warm core low. Okay. So you literally are creating a mesoscale warm core low, much like what you would see with a tropical low. It's the same process, just far more enhanced because it's all fire. So it is nasty. That is for sure. This reminds me of 1976 for our area. Not a ton of snow, but very cold, bitterly cold air. But the next two winters after featured more snow in 77 and 78. I do think I get what you're saying. One of the things I'm going to be watching very carefully now that we reached our solar maximum, as we go into our decline, if we start to see better potential for disruptions of the polar vortex, better potential for high latitude blocking, and more of alignment of the jet stream such that we enter these winter storms. I do have a weak theory. It's a theory. I haven't proven it yet, but I'm looking at the correlation between, and correlation is not causation, but I am seeing a trend where our worst winter weather seasons happen to be when we have our solar minimums. And we just hit a max, and all of our maxes, like even the mid to late 80s. And I wrote this earlier in Discord under the premium section, um, where our least snowy winters also happen to be when our solar activity was at its highest. So I haven't created, I'm still working on how do you physically drive that? Is it based on what's going on with the polar vortex? Maybe that's part of it. How maybe the nature of the stratosphere influences tropical forcing. That could be part of it. So I'm still working on the physical parameters on how that's connected, and I still got a long way to go on that. Some of the equations are still off, so I'm still working on that. But there's definitely a trend showing up there, so I'm working on that to see if it actually is something that is real or if it just happens to be a coincidence. So that's something I'm certainly studying and keeping an eye on. Let's see what's going on YouTube. There is a lot of questions here. Let's see here. And of course, when we go into social media, I always try to find the best one. And if you're wondering which ones are the best ones, they are not the ones that ask whether I'm going to have X amount of snow in my backyard, just so we know. Uh, can you please explain why Philadelphia is now the only place in the Mid Atlantic that has missed getting 10 plus inch snow since the blizzard of 2016? Honestly, okay. The past couple of years, we've been dealing with a lot of Miller B storms, which are storms that kind of redevelop from the Ohio River Valley and then towards the um, towards the coastal waters. And as we saw with the previous storm that we just dealt with, which was not forecasted very well by me and the National Weather Service and pretty much everyone else, in terms of that moderate band, a 3 to 6 inch band, that just collapsed. And I wrote a reason why that was the case in the premium section under the storm analysis. So definitely check that out, premium members. In that scenario, when you're getting a transition, you're going to kind of get this lull, this weakening of the precipitation shield. And sometimes that happens over central Pennsylvania, and sometimes that happens over southeastern Pennsylvania, say from York to Philadelphia. And lately, the past 2 years at least, it has really been focusing in that area. And part of that is luck. Part of that is the way that the transition is occurring. The storms are getting kicked out to the east because the blocking isn't as strong in the Atlantic. And so you're getting that transition period and that subsidence right over Philadelphia. That won't always be the case, but that is essentially what you're seeing and what you're observing. When you have Miller A storms, where the storm just comes right out of the Gulf. It doesn't do any transition. It just keeps on marching along and intensifying. You don't end up with that scenario. You just get one area of heavy precipitation marching its way up through the I-95 corridor. And you don't have to worry about any of those transition issues or anything of that nature. So that's why you're seeing that quite a bit. We haven't had a Miller A in quite some time, at least not one during the winter months. Let's see here. Let's see. If the storm were to trend northwest, I'm guessing you mean for this Saturday. No, there is no trend. You, the pattern configuration, the way it is right now, eliminates any trend in any way, shape, or form. The only thing that you're going to see change in the model guidance for Saturday is that the polar shortwave is likely going to be a little bit stronger. You might have a little bit more convective element to some of the snow showers on Saturday morning, which might push you into that 2-inch range. But that's about it. That's it. There won't be any trend to the northwest. Let's see. Uh, Will the polar vortex remain really strong the entire winter? Yes. The reason why is because your QBO is still westerly. When you have a weak polar vortex, what typically happens is that your QBO is easterly. Okay, that isn't always the case. It's not 100%, but that's usually the rule. When you have a strong polar vortex at the start of the season and you have a westerly QBO, that's enhancing the polar vortex. Now, this year we're seeing a lot of stretching, which is also kind of a theme of a westerly QBO as well. But you're not seeing a destruction of the polar vortex like we did last year, where it just basically got obliterated. Um, and even in that scenario where it got obliterated in a negative QBO, it was so strong to start off with that it took a while for it to break down, and really the influences of the destruction of the polar vortex were felt more in late February and March, and led to a chilly early spring rather than a very stormy winter. So again, timing matters as well. But in this case, there's nothing really to weaken the polar vortex. I expect it to remain strong, just stretched out quite a bit. Let's see here. No, nothing about. Did you see much thunder snow during lake effect storms at Oswego? Oh yeah. Oh, the main reason I went to SUNY Oswego. I mean, I love the teachers and the campus, and that's all. But let's be frank. I made my decision on going to Oswego when I went to go visit the school, and I got to see a lake effect snowband come right in. There is anyone who loves snow and they see that, and that can happen almost every day in November and December. You don't have to say anything else. That's it. That was the selling point for me. The professors look great. The curriculum was awesome. The SUNY schools are very good. They're great to go to. They're fair. They have a fair price as far as the costs for student loans. Um, but that did it right there. I mean, geez, just experiencing the lake effect snow uh, environment is just you can't beat it. Oh yeah, the class size too. Well, let's see. We started off with 30. We ended up with 3. So yeah, our freshman year we had 30. Let's see here. Sophomore year we were down to 6, and then graduation we were about 3. 3 survived. So It's kind of like Highlander over there. Everyone getting eliminated. You know what did it? It was the Calculus 3. Calculus 2 got some people out. Calculus 3 really was the nail in the coffin for a lot of people. And I remember, I think it was, yeah, my sophomore year, I made the mistake of taking Calculus 2, dynamic meteorology, synoptic meteorology, chemistry, and physics. And that all came to a head when I had all of my finals on the same day. And by the end of the day, I kid you not, I could not remember how to write my name. And one of the professors, he came to me, he's like, why don't you take a 10-minute break? You could walk out of the room and then maybe you could, like, I was just sitting there, I couldn't write. Like, I literally, my brain was done. But I stepped out, had some water, threw some water on my face, aced the test. But there was a point, literally, I couldn't even think. I literally couldn't even write my name. Oh boy, that takes back memories. But at the same time, I don't know if they still have this there, but they had chocolate covered coffee beans that were amazing. All right. And man, that got me through a lot of tests, a lot of finals. Chocolate covered coffee beans and Slim Jims. That was the diet of choice for college education me. Let's see here. Why was the winter of 2019 and 20 so warm and snowless? Great question. The polar vortex. I remember this specifically because we were down at my parents' for Christmas, and right around December 20th, we were looking at the model data. I was looking at the model data, and I just saw the polar vortex go into a big circle right over the Arctic. And it was at that moment there where I knew the winter was shot. Because basically, what that does is it traps all the cold air into the Arctic, and you can forget about any type of cold air transport or anything of that nature for at least 8 weeks, which by that point takes you to about mid February. And then when you get to mid February, yeah, you might get some cold shots, but you get a lot of moderation at that point because there's no snow in the United States because of that. So any cold air mass that drops down basically warms very quickly, moderates very quickly. So when I saw that, I made a post the next day. I wanted to wait for a little bit more data to see maybe it was just a flaw, maybe it was just an error, but no, it was real. And then I'm like, yeah, that winter forecast, you could take it and burn it and throw it away. It's done. Because once I saw that, that was it. That was it. And part of being a meteorologist is also admitting when you're wrong. Okay. Like, for example, the storm we just had, I quickly admitted, like, hey, look, central New Jersey looks good. Southern New Jersey looks good. Overperformed in Northeast PA. Southeast Pennsylvania was a complete dumpster fire. I admitted immediately, like, hey, that didn't work out. This is why it didn't work out. When you do that, if you want to be a credible meteorologist, I'm not talking about hyping and getting the most channels and all that shit. I'm just talking about being credible. What you need to do, and this took me some time, especially in my 20s, I didn't like doing this. You have to take your ego out of it and just say, okay, this is what I did wrong. This is what I need to do better. These are the errors I saw. And when you can do that, that is when you become a great meteorologist. Because then what you could do is find your own bias. And when you can find and correct your own bias, that makes you a better forecaster. You're going to be wrong. You're going to make errors and make mistakes. You're talking about forecasting for chaos. You're going to make mistakes. But if you are open enough to say, hey, this didn't work out, now let me go find out why it didn't work out and explain it, that makes you a better forecaster. And that never ends. I could be 80 years old doing this, and I will still make mistakes, find those mistakes, and fix them and learn from them. That's why I love meteorology. There is no expert that knows everything, ever. There is never anything settled in this science. It is constantly pushing you to be better. So there's that. Oh, let's see here. On YouTube. Let's see here. What does studying calculus 1, 2, and 3 got to do with meteorology? Oh boy. Uh, hold it. Hold it. Let me pull out. Let me get something here. Let's see. Yeah, let me get this here. No Godzillas have been taken out. Okay. I got this book for Christmas, which I am very much enjoying. I'm reading a chapter each morning after I get done forecasting. In order to understand all of the factors involved with everything going on, let's say with just tropical forcing and just understanding the various nature of interactions in the tropics, you have to understand a lot of the equations here. I don't know if you can see some of the equations. Trying to point out here. There you go. Okay, so that's a very simple one, right? When you're studying atmospheric science, it's not just looking at a satellite picture or looking at model data. The reason why I know when to look at model data and say that's BS is because in my head, and I'm sure in other heads of meteorologists, we have those equations stuck in our head. And here, actually, you know what? Let me see if I can pull this up. 1 minute here. Because what I want to show you, I guess maybe I can't, a list of all the equations that we study. And unfortunately, I'm not able to pull it up, but every equation in the atmosphere is based on this scenario of understanding here. Hold it. Let me pull this up here because I really want to show this. Okay, give me 1 second. Okay, good. Okay, there we go. This is the basics. Say hello to working all of these equations out. Okay, now a lot of these equations, when you're dealing with these equations here, what you're studying are the ranges and the chaos involved in each atmospheric motion. So, for example, the equation of vertical motion is here, equation of state, Newton's second law of motion. This one was a pain in the ass back in college. For some reason, I could never get this equation right. Not calculating it, but just remembering how to write it properly. And I had a professor at Oswego named Dr. Scubis, who was, I think he's still there. The man loved this math, loved it. He was so excited. I wish I had the joy that he had doing multivariable calculus. I can't do it. I could do it. I just don't have the joy and the excitement of it. So when we're talking about temperature advection, this is the equation we're talking about here. Okay, let's zoom in. This is your temperature equation. This is your precipitable water equation. Now here's your pressure thickness. Now, why is it important to know these equations? Well, if you don't know these equations here, then what happens is that you can't pick out modeled error. Because if you don't understand model error, if you don't understand equation of continuity, when you're applying it to conservation of mass, then you're not going to be able to pick up when the models are wrong and understand why they're wrong. It's easy to say, oh, X, Y, and Z model is wrong. Why? What is the mathematical reason behind it? So you start off, you don't just jump to calculus 3. You start off with calculus 1. Calculus 1 really has very, very little to do directly with meteorology. But it's the stepping stone to get to calculus 2 and then calculus 3. So in order to understand these equations and mathematically work on them, you got to be able to understand how to get there. And so you start off with calculus 1, then you work your way up to calculus 2, and then you lose some more hair, or you start drinking, whichever. And then you do calculus 3, and then you stop drinking and you go and start working out at the gym more, because then you start losing your mind. Okay? So that's essentially how that works. Let's see here. Yes. What would you like to address? Yes. Mhm. Yeah. Yeah, I think that'd be a great idea. We'll take down the whole library, because literally a lot of these books are great. Um, and we'll go over them. A lot of these books you can get on via the AMS, American Meteorological Society, and also find them on Amazon. But one book I will say definitely that every young meteorologist should have, and typically already asks for, is the Colson Mussolini book, Northeast Snowstorms. That is a must. That is definitely a must. It was probably, I literally, when I got that book when I was, what was I think I was 13 or 14, that Christmas, and my parents couldn't find me the rest of the day because I was just hiding away reading the whole book. Now, there's some technical terms in there and some equations that at the time I really didn't understand, but it was a good exposure. But it also has a lot of great information about the history and what was observed and why certain factors were important in the storm. So it's a great tool to start learning in terms of understanding atmospheric science. It's a good stepping stone. Yeah, absolutely. That probably, that, let's try to shoot for that to be like the first spring. Yeah, yeah, like maybe like that first week. Yeah, once we get like maybe like mid to late March, we'll do one of those. Let's see here. Going back to the live chat here. What kind of temperature range do you see over the next couple of weeks in New York City Metro, but also we'll do the rest of the region? Generally, I think we're going to see, as far as lows, we're going to see a lot of mornings where we're in the teens and 20s. And highs, I think we're going to see a lot of days where we're struggling to break 30. I really do. Um, and then as we get past mid February, we'll start getting closer and closer to more 40s on average. Excuse me. So is say hello to my equations to meteorological equivalent of saying hey, hello, say hello to my little friend. Yeah, yeah. Anytime someone says, you bust, or something like that, I am so tempted to say, when you could do this equation, when you could derive this equation, then you can come and tell me that I'm a bad meteorologist or I bust or anything like that. When you could do the math, then come to me. Okay. Otherwise, I don't want to hear it, because quite frankly, there's no one more critical of my forecasting than me, right? I mean, how many times have you said you're not that bad, and I'm like beating myself up for like hours? Yeah. So yeah, you don't need to tell me I bust. Trust me, I know. Let's see here. Anything on X or Facebook? Ah, well, typical. Do you think the polar vortex will split this winter? No. It won't split. Wrong. There's a better chance of seeing a split in the polar vortex next year. If we actually get an easterly QBO, I'd watch out for that. Sure, and I'll see what we got here on YouTube. Let's see. Curious to know more about you. Is YouTube your principal source of income? Do you work for the National Weather Service? No, I do not work for the National Weather Service, but I know a lot of people who were at the National Weather Service. I actually know, I actually work with, and they're great in the New York office and Philadelphia office. They do an outstanding job. Um, my primary, I guess, say, living is NYNJPA weather with premium membership for only $15 a month or $150 a year. So definitely check that out. It's definitely worth it. Let's see. Joe says, I remember years ago winter storms had no problems forming. Today it's like hitting a Mega Millions to get one. Yeah, I mean, look, we're in a very similar pattern in terms of the interaction of shortwaves that we saw in the mid 1980s. I did some comparisons on the weather patterns and 500 millibar patterns. They're very, very similar in terms of the pace of the short waves between the subtropical jet stream and polar jet stream. Now, there are some factors that you have to take into effect, like yes, global warming, yes, influences from volcanoes, and stuff like that. But the overall theme that we saw in the mid 80s and early 90s and in some portions of the early 2000s was very much the same, where it felt like we'd never see a winter storm. But then remember in the mid 90s, parts of the early 2000s and especially the late 2000s and early 2010s where it was like one storm after another. We always go through these phases. And the same thing goes for tropical weather too, where you get these phases of a lot of tropical systems impacting the United States and then not so many in other decades, and there is a push and pull on that. There are some factors that include the state of the PDO, the state of the Atlantic multidental oscillation, uh, the state of the polar vortex. All these factors all come together. One thing to always remember, it's not always just one factor. The atmosphere is a chaotic monster that that is constantly changing its fluid dynamics live right in front of you. You're living in it, and that fluid dynamic that's constantly changing is constantly creating chaos. So what you have to do is look for the patterns within that chaos. And right now, this year and past couple of years, it has been tough. But let's be honest here as well. This year is far better than what we had the past couple of years. Let's be honest about that, especially in December. December, we had that one winter in 2020 where we almost had no snow at all. So there you go. We're already batting 1,000. Let's see. Let me go back to, let's see. Let's see. Absolutely. If you forecast bust, you acknowledge it. Note that even in the 80s, the drought years, we did have a couple of nice storms. Yes, we did have, and I think we will this year. I do. I do think we have the potential. Hopefully, I didn't jinx anybody or anything, but I do think we have the potential. Let's see here. Differential equations, got engineering class. Yeah. What causes a Norlon trough? Typically, what you want is an upper level low for us, for our region. You want upper level low over Western Pennsylvania or or Western New York, and a new upper level low forming off the New Jersey coastal waters or the Delmarva Peninsula. That setup creates stretching in the atmosphere, which leads to a trough. So kind of need two anchors, and one anchor is over the Eastern Great Lakes, the other anchor is off the Mid Atlantic coast, and the transition from this feature to this feature leads to stretching in the atmosphere, and so that leads to your powerful trough. Um, that's typically what you want. What you want to look for. Do you think quantum computers will have an impact on computer models from now? It's going to be fun. Here's the problem with improving computers. Absolutely they're going to help. It's not going to matter if you don't have good quality data going into it. There's the rub. We're all talking about, oh yeah, look, AI, blah blah blah. Yeah, that's all cute and all, but if we don't have good observations, if we have holes in our observations, it isn't going to matter. I'm sorry. I know that everyone's all excited. I just had an AI bot tell me that I have 7 fingers. Okay? All right. AI is a wonderful thing, kind of, unless it becomes Terminator. Then maybe not so much. But, but it's not foolproof. And some people are like worshiping it. It's like ridiculous. But according to AI, um, let's see here. Some things that AI was wrong about so far. It said that the Mets weren't going to make the playoffs. See, it's garbage. Clearly, the Mets made the playoffs, and also they should have won the World Series, but you know, MLB doesn't want them to. But clearly, the AI was wrong about that. So I would say that look, it's going to be an interesting tool, but that's all it is a tool. That's all it is. And if you let it replace the meteorologist, you're going to get worse and worse forecasts. I mean, if you don't believe me, just go check the Apple your Apple phone and take a look at the forecast every 15 minutes. Looks like space weather has the regular images back. Yeah, they looks like they fixed it, so that's going to be great to see even more data. Although I will say that a lot of the volunteers did an outstanding job with covering the missing data. They really did a great job in that respect. Let's see here. The EPO is parked to go negative along with the AO and NAO. Will the storm pattern be different and more active? Yeah, I mean, those are really strong signals. Now, look, when you're looking at the signals, understand that is not a guarantee. But I'd rather be in an environment where you have a negative EPO, NAO, and Arctic oscillation than a positive one. Positive, you have no shot. Negative, hey, you're in the ballpark. You have a chance. You may hit a home run or you may get a bunt, but you got a chance. That's where we're at right now. We are in a situation where you have a chance. And look, after the past couple of winters where you had no chance, that's at least an improvement. Let's see here. Okay, the 1980s featured a polar vortex that typically was strong, and you had a lot of tropical. You had a lot of La Ninas too. That I noticed as well. But really, the primary theme was the polar vortex just kept all the cold air bottled up. We're having a good night. These are some great questions. It's already 9:03. I didn't even realize that. Wow. Holy smokes. I was having such a good time. You guys were asking such great questions. I forgot what time it is. All right. So, this has been a great night. Just to recap a couple of things, our low pressure system for this weekend looks to be light. It'll be a nice look. Wake up Saturday morning, nice cup of cocoa or coffee, whatever you might be drinking, or stop drinking, whatever that might be. Just go open up the window. Hopefully, you have clothes on. Please do that, and just enjoy it. Yes, I know it's not 3 feet of snow. It's not 30 inches like some of the models. Both the European and the GFS was trying to show that. So let's not just trash the GFS. It's not 30 inches. I get it, okay? But it's still going to be nice to look at. And look, life is short. Enjoy it. Enjoy the light snow. And the fact that you won't, at least when you clean off your car, you won't get back strain by shoveling 30 inches of snow, right? Exactly. And then we have a couple of other storms. We have plenty of cold air. There will be no lack of cold air. And we have some storm threats that we have to monitor. But for the love of God, do not go into details on any of these storms until we get under 168 hours on the model. Once we get under that point, 168 hours out, then we can start looking at snow maps and the storm tracks. And then we could start to pretend things trended northwest and southeast and northeast and all around. But don't bother doing any of that. And please don't bother waiting and staying up all night for the zero Z guidance until we get under that point. In fact, I'm going to change that. Get under 120 hours, then start doing that. Trust me, sleep is more important than waiting up. When you wake up in the morning, you'll still have those models still waiting for you. So that's it for tonight. Outstanding chat. Thank you very much for joining us. And thank you for the wonderful questions. And I will see you here next week. Same time, same place. In the meantime, stay safe out there.